The moon. An object that has inspired humanity for centuries, a subject of poems and tales due to its magnificent appearance. Aside from the occasional small rocks that orbit our planet, it is our Earth's only natural satellite. But what if one day the moon suddenly disappeared? Could our planet continue to exist, or could life on Earth go on, do you think? In the beginning, there was chaos. In the early formation periods of the solar system, there were not just 8 planets. Numerous protoplanets had formed, and they did not have regular orbits like today. They were colliding with each other ceaselessly, scattering giant rock pieces across the solar system. One such protoplanet, called Theia, and estimated to be the size of Mars, collided with Earth with full force, causing a large amount of mass from our still not fully cooled planet to scatter into space. This mass coagulated around our planet due to Earth's gravity. And so the moon was born from these rock pieces, that is, the parts that formed Earth. Quite poetic, isn't it? This birth process lasted approximately 30 million years. So if we were to condense the entire 4.54 billion year existence of Earth into 24 hours, Earth would naturally exist at the 0th second, and the moon would come into existence at the 10th minute. When the moon first formed, it was very close to Earth. Only 25,000 kilometers separated us. Think about it, that's not even half the circumference of the Earth. The moon was that close to us. If the moon was still that close to Earth today, we would see it 15 times larger in the night sky than it is now. But then, due to the moon's gravitational pull, our planet's crust would experience tremendous tides and therefore reach abnormal temperatures. As a result, life could not exist on the surface. Fortunately, the same gravitational pull causes a small portion of Earth's energy to be transferred to the moon during each tidal occurrence. Because of this energy transfer, the moon drifts towards a higher orbit and hence has been slowly drifting away from Earth since its formation. Thanks to laser measurements, we know that the moon is currently moving away from Earth at a rate of 3.78 centimeters per year. But let's put aside the slow drifting for now. What if we suddenly made the moon disappear? Would Earth crack and explode, do you think? No, at least not immediately. The sudden disappearance of the moon would not have such a drastic immediate effect. Our nights would simply become darker, and we would be deprived of the beautiful sight in the sky. We can experience a little bit of how dark a moonless world would be during the new moon phase. Think about it this way. We measure brightness in magnitudes, a logarithmic scale where smaller numbers correspond to brighter objects. For instance, the sun's magnitude is at a level of negative 26.74. The full moon's is at negative 12.74. It seems like there's a halfway difference between these two numbers, but the logarithmic scale can be quite misleading. In reality, the difference between these two numbers is not 50%, but exactly 401,995 times. You can better understand this when you consider how much brighter the sun is compared to the moon. Consequently, a phenomenal cycle of climate change would begin. For instance, during the periods when we entered the Ice Age, everything except for a small strip around the equator might have been covered with massive glaciers. We are seeing a similar scenario on the red planet. Mars's moons can't stabilize it, leading to estimations that its axis oscillates between 0 and 60 degrees over millions of years. This causes seasons on Mars's surface to constantly shift from one extreme to another. So far, I've discussed what would happen if the moon disappeared today. However, we could also contemplate its absence in earlier stages of Earth's geological evolution. Currently, Earth's rotation is slowly decelerating due to the gravitational pull of the moon. As we've discussed before, this deceleration lengthens Earth's day by about 2 milliseconds every 100 years. Thus, if the moon were to disappear today, this deceleration would vanish, although this change would go unnoticed. But if the moon had disappeared or never formed shortly after its creation 4.5 billion years ago, Earth's rotation would not have settled to the current 24-hour cycle. Depending on your assumptions, our day could have been as short as 4 hours. This shift in speed alone would have a multitude of effects on Earth's life, which I'll leave for another video. If you find these types of videos intriguing, don't forget to enable channel notifications. One of the most disputed effects of the moon's disappearance is whether it would alter Earth's orbit around the sun, as I've previously explained. Actually, the moon doesn't revolve around the Earth, and the Earth doesn't revolve around the moon. Instead, they both orbit a common point known as the barycenter, determined by their respective masses. As Earth's mass is 81 times greater than the moon's, this center of rotation is a point very close to the Earth. This point is precisely 4,641 kilometers from the Earth's center towards the moon. Since the Earth's radius is 6,371 kilometers, the Earth-Moon barycenter lies within the Earth, not at its center as many believe. This is why Earth wobbles slightly in its orbit around the Sun. If we were to suddenly remove the Moon, this barycenter would shift to a point very close to the Earth's center, potentially altering its average speed. According to calculations, this change could increase or decrease Earth's orbital speed around the Sun by 0.041%, depending on the Moon's position relative to the Earth at the time of its disappearance. As you might remember from the orbital mechanics video, every orbital speed corresponds to a specific orbital altitude. Therefore, if Earth's speed changed, its orbit around the Sun would also change. However, this would be an incredibly minor adjustment, as Earth's orbital speed isn't constant everywhere. While revolving around the Sun, the Earth moves closer and farther away, varying between 147.5 million kilometers and 152 million kilometers. This isn't just a matter of a few meters. Earth gets 4.5 million kilometers closer and farther from the Sun each year. So we already experience this kind of orbital and velocity variation naturally. Indeed, in many simulations, the disappearance of the Moon has no effect on Earth's orbit around the Sun, but theoretically, depending on the precise moment the Moon disappears, this force change could make Earth's orbit slightly more circular or slightly more elliptical. In comparison to everything we've touched upon so far, the impact of this slight shift would be relatively insignificant, and to actually see a meaningful difference, we'd need to wait millions of years. I'd love to delve into the famous three-body problem in physics to provide a clearer understanding as to why millions of years would be necessary, but there's not enough time in this video. Let's save that for another video. Furthermore, of course, there could be sociological effects from the Moon's disappearance. For instance, due to darker nights, we could see a spike in crime rates. Science and technological advancement could also be impacted by a moonless night. You see, many rocks dating back billions of years have been melted and lost due to the Earth's active tectonic activity. However, as the Moon is not particularly tectonically active, records dating back 4 to 4.5 billion years remain frozen in place there. In other words, by studying the Moon, which came into existence from pieces of the Earth, we can explore the history of our planet. If there were no Moon, these records would not exist. Moreover, one could only imagine the panic that would ensue among people if the force that could suddenly remove the Moon had an immense power. Ultimately, consider the energy necessary to remove the Moon from the Sun's orbit. Recollect the video where I described the energy emitted by bombs like the atomic bomb. Imagine again the 1 megaton hydrogen bomb from there. Right, to knock the Moon out of orbit, we would need to detonate one of those bombs every second. This process would need to continue without pause for 288,000 years. Just imagine what else a force capable of doing this could achieve, be it an inanimate object like a black hole or a sentient civilization. Everything I've told you so far are some effects that are commonly discussed in popular science and expected to occur as a result of the Moon's disappearance. However, some sources tend to exaggerate these outcomes. For instance, we mentioned that the disappearance of the Moon would wreak havoc on the axis tilt. However, some models suggest that at some point, thanks to Jupiter's gravitational pull, this wobble could stabilize again within a narrow range. Or we mentioned nocturnal hunters would struggle. Yes, but their prey would gain a tremendous advantage. Discussing only disaster scenarios without considering these aspects may be beneficial for garnering attention, but it doesn't necessarily reflect the truth. For example, some sources mention that the Moon shields the Earth from meteors. Well, the Moon is about 236,000 miles away from the Earth, but it only has a diameter of about 4,000 miles. The sky encompasses an area of about 41,253 square degrees from which meteors could potentially come from. Yet the Moon only covers about 0.25 of these square degrees. I'll touch upon Lagrange points at some point, like the L2 location where the James Webb Telescope went. These specific equilibrium points are quite weak and small for the Earth-Moon pair. So, for instance, there's no Lagrange point protection like what a massive body like Jupiter provides. In other words, the chance of the Moon shielding Earth from meteors is next to none. But doesn't it sound cool when stated? Not many people talk about the probability of a meteor that wasn't going to hit the Earth in the first place being deflected towards it by the Moon. Or we said, if the Moon disappears, food chains would be disrupted, species could be driven to extinction. Yes, they could be disrupted and many species could vanish. But life has faced events far worse than this numerous times throughout Earth's history, and life has always found a way. Of course, this doesn't mean life will certainly prevail no matter what happens to the moon or Earth. Something could occur that wipes out all life. In the end, there's no guarantee of our existence, but we need to understand that not every disaster scenario spells the end for Earth or life as we know it. What about evolution? The disappearance of the moon could lead to catastrophic results, yes. However, considering that most impacts would gradually and slowly manifest and that many effects would emerge in the medium to long term, it's not very likely that life would be wiped out just because the moon disappeared. Quite the contrary, life, which has adapted to much more destructive events, would probably adapt to the moon's disappearance through evolutionary mechanisms and carry on. Because we can't know the alternatives and we've opened our eyes in a universe where the moon orbits the Earth, we believe our current conditions are the best possible. We've talked about this before. In reality, we can imagine planets with conditions far better than Earth for diversification and persistence of life. Those planets don't necessarily have to have a moon. That's why I suggest you not dwell too much on narratives like, if this had or hadn't happened, Earth would be such a terrible place, life would be unbearable. Without seeing the entire spectrum of possibilities, we can't conclude that what exists now is the one and only best situation. Given that, as of the day this video was filmed, we've identified only 4,980 planets. Yes, a minuscule number out of the quadrillions of exoplanets orbiting trillions upon trillions of stars in the universe. We must remember that our knowledge about the possibilities is extremely limited. What do you think awaits us out there? Until the next video, take care.